here it asks us to simplify using the quotient of powers property, and we have x to the power of 3 times y to the power of 4 divided by x to the power of 2 times y. And we can go ahead and apply the quotient of powers property, and what we can say here is this is going to transform into x, because we have an x in the numerator and we have an x in the denominator. So say x to the power of the x in the numerator, 3, minus the power of x in the denominator, minus 2. Right? And then we can also transform the y, so we could say y to the power of 1 minus 1. Why? Because the y in the numerator has a 4 and the y in the denominator has a power of 1. So we'll go ahead and do the subtraction, and we'll get x to the power of 1, that's just x, times y to the power of 3, and that is our final answer. Let's go ahead and look at this one here. We have 2 times k to the 7 times m to the 10 times p. We have 8 divided by 8 times k to the 5 times m to the 3 times p. So let's go ahead and do that. We could say equals, and maybe we could say keep the fraction as 2 over 8, and let's go ahead and rewrite all of these variables with exponents using the quotient of powers property. So here we'll say times k to the power of 7 minus 5. We'll do times m to the power of 10 minus 3. And we'll do p to the power of 1 minus 1. Right? So let's go ahead and rewrite all of this, and we'll say it's equal to, and we'll divide by the greatest common factor of 2, and we'll get 1 over 4 times k to the power of 2 times m to the power of 7, and here we have p to the power of 0. Let's go ahead and write that out, p to the power of 0. Right. Now this is going to go ahead and transform, because any number to the power of 0 is 1. So what we get here is 1/4 times k squared times m to the 7 times 1. But that times 1, any number times 1 is just that number. So this p to the 1 just kind of cancels out. Right? So our final answer is going to be 1 over 4 k squared m to the 7. And I'm going to put a box around it.